This is the first video on section 2.4 on projections. And what I'm going to do here is I'm going to talk about definition 52 and note 53 on the projection of one vector onto another. So here we're going to look at we're going to start with two vectors, v and w. We're going to project w onto v. We're going to talk about the scalar projection of w onto v and the vector projection of w onto v. There are four basic scenarios. Two of them are really of interest. The other two I will talk about at the end in passing. But the first is the angle between the two vectors is an acute angle. So it's strictly between 0 and pi over 2. That is our first case. And so what is the projection of w onto v? Well, we start here at w and we drop a perpendicular onto v. This vector right here is the projection of w onto v. And so now we're going to just look at some properties of this vector. First of all, we can get theta or cosine of theta two ways. One is simply using the adjacent divided by hypotenuse definition of cosine. So the length of the adjacent side is the magnitude of the projection, and the length of the hypotenuse is the magnitude of w. That is one way to calculate cosine of theta. What's the other? Using the cosine formula with w and v. So we take the dot product of v with w, divide by the product of their magnitudes. We set these two things equal to each other and then solve for the magnitude of the projection, which is going to be v dot w, the dot product of v and w, divided by the magnitude of v. That is in the case that the angle between the two vectors is an acute angle. What if it's obtuse? So we've drawn it this way. We have our vector v here. We have our vector w. I did not draw it as a vector. There we go. Now it's a vector. So we have our vectors v and w. The angle between them is obtuse. We're going to look, if this is v, this vector here is negative v. So negative v, it has the same magnitude of v, goes in the exact opposite direction. This is negative v. So what are we going to do? We're going to calculate cosine of alpha. Alpha is this angle right here between w and negative v. Cosine of alpha is adjacent divided by hypotenuse. So it's the magnitude of the projection divided by the magnitude of w. Calculated another way, it's the dot product between negative v and w divided by magnitude of negative v times magnitude of w. We set these two expressions equal to each other, solve for magnitude of the projection, and we simplify a little bit. So remember from our properties of the dot product, the scalar multiple negative 1 v dot w is the same as negative 1 times the number v dot w. The magnitude of negative v and the magnitude of v are the same. So again, we solve, we simplify. Now, let's see. Let's talk about the other two situations. The other situation is the angle between these two vectors is 0, in which case w comes along here, and so the projection of w onto v is simply w. The other situation is what happens if theta is pi over 2. Then you have this angle right here is a 90-degree angle, or pi over 2 radians, in which case the projection down onto v is simply the 0 vector. Those situations are not quite as interesting, but they do exist, and so they're in your notes. This calculation, v dot w divided by magnitude of v, this is called the component of w along v, or the scalar projection of w onto v. And this vector that's the projection then is Well, it's kind of a complicated calculation. I'll tell you how I remember it. You remember the component. This is a scalar. This is a number. What is v divided by magnitude of v? This is the unit vector in the direction of v, this part right here. So what we do is we take the unit vector in direction of v and we multiply it with the appropriate scalar. That gives us the vector we want. So this is how I remember the calculation generally. It simplifies to this. So now we're going to look at example 54. We have a vector v, we have a vector w. We're going to do three calculations. First, we're going to calculate the scalar projection of w onto v. That's just a matter of using this formula right here. We take the dot product of v with w, we have 25. We take the magnitude of v, we have the square root of 35. This is a number. Scalar projection's a number. Then we have the projection of w onto v. For that, let's go back to one of these two formulas. We've already calculated this. So we have our 25 divided by square root of 35. We've already calculated that. We have another magnitude of v in our formula. We've already calculated that. This is our scalar for v. Square root of 35 times square root of 35 is 35. This fraction simplifies. So we have 5/7 is our scalar, and this is our vector v. So that's the projection. And finally, we want to find the angle between v and w. According to the cosine formula, cosine of theta is simply the dot product of the two divided by magnitude of v times magnitude of w. Since 35 and 21 both have 7 as a factor, we can simplify this a little bit. That is cosine of theta, but we were asked to find theta. So what is theta? Well, it's the inverse cosine of that number, or arc cosine. And so part C is continued right up here.